Hi and welcome. This time around I'm going to attempt to make my emblem out of brass, and it'll be buried in epoxy so that I can take slices of it and use it to put on the tools I make. Hopefully it'll be clearer when I proceed further. I have never attempted milling things this thin and leaving profiles this thin out of such soft material. I might need to change materials from brass to something like stainless that's a bit stronger, but we're going to give this a shot. So first up, I'm going to take this piece of 50 thousandths brass stock and glue it to this piece of aluminum, and what that'll allow me to do would be to mill it down to 30 thousandths thick in the middle sections, because I don't know if you can see this, but there are some little spurs sticking up, so I'm going to be taking 20 thousandths off of this material. I have two versions of this. I have one with the straight T and one with the tilted T, which I kind of like. We might try both, but initially let's just see how this goes. So I've got to sand these materials, get some super glue in here, put this in the press, in the hydraulic press, and squeeze it together until the glue sets. So here we are at the hydraulic press, and down below here is the aluminum. Just above it is the thin 50 thousandths brass, which you can't easily see. Above that are a couple steel plates, or cold rolled steel plates, that are just for pressure spreading. And I'm going to leave this here. I didn't crank on the pressure too much. Just put some pressure on it until it gets a chance to cure, you know, maybe a few tons pressure. I didn't really push this thing hard at all. So I have no idea if I'm going to be able to pull this off, because I want to get this all the way up to within 50 thousandths a side. I don't know if you can drill that close with potentially tearing it, plus I want to go in about an inch. So I have no idea if this is going to work, but let's start with center drilling and we'll play it by ear, right? Live and learn. Using the DRO I built into my tailstock to set depth. I'm hoping because this is brass I'm going to get away with this, but I don't know. Chips are kind of packing in the end here. Should have retrieved it sooner. It just seemed like it was cutting really well. Alright, next up what I'm going to do is, instead of using the next size up drill, which I was going to do 3/8, I'm going to switch to a 3/8 inch end mill, hoping that that will get a straight cut like a reamer, and then when I go to the about 400 thousandths, we'll see how that looks. So as you can see, this is 0.375. I want to hit 0.4, and you can see it's already looking really spooky. So I don't know, we might slow this down a little bit. Let's try 300 RPM, see how that works out. And I'm obviously going to have to peck with this. Alright, so the closest I have is this letter drill. It's an X, it's 0.397, so the thickness of the wall will be a little over 50 thousandths, but I don't think it'll matter, it's only 3 thousandths over. So we're going to give it a shot here. It only needs to take off a little bit of material, so... Okay, that worked out all right. So in the base here I have the piece that is going to serve as the mold base for this assembly from my Dudley Tool-Rite, and I'm going to mount this guy in here, and I need to drill this off center as per my drawing, and then I'm going to mill half of it off so that you've got just part of the D. So this whole thing is going to sort of serve as a fixture where I will cover the outside with metal and then fill this with epoxy, and all of the individual brass pieces, the flats and whatnot, will be contained inside and buried in epoxy, and then I will mill it flat so that I've got my DT exposed. At least that's the plan. So first we've got to get this thing centered on the mill, and we'll use the Blake coaxial indicator. Since my coaxial indicator is a 3/8 inch shaft, I've got a 3/8 inch spotting drill, and the pip where I turn this should be dead center, so that let me get really close. Then I can bring in the final bit with the coaxial. So I've got the mill centered on this part now, which will be my sort of my mold base, and each one of those divisions is 1/2 thousandth, so we're off a couple of tenths. And I zeroed my DROs, so I've got my 0 point in the middle. Now I can dial in an offset to go off the edge and mill the hole. We're going to take a 1/2 inch end mill, and we are going to drill a recess for this guy to go in. We're not going to go down that far. So we're going to try 500 RPM here. This might be a little bit fast. Yeah, some chatter. All right. So we're going to go to back here. And I probably should drill a center hole first, actually, because even though this is a center cutting end mill, it's a lot harder on it. Actually, it might not be a center cutting end mill. Looking at the pattern there, yeah, it might not be. All right, we're going to go grab a center cutting bit and pre-drill this hole. All right, so here we go with the center drill. And we're going to follow that with a 1/4 inch. Here's the 1/4 inch. Still a little high in the RPM range. That was 1,000. Maybe down to like 700. Onto the 1/2 inch end mill. Put it up to, say, 200 RPM. That's too cold. Try 340 RPM. Okay, and we're good. So some floor planning on my part. I did score vertical and horizontal lines in here, but if I'd been really smart, I would have taken this guy and thrown it in the vise first and put a flat on one side so that I'd always have a reference side. Now I'm going to have to try and line this guy up. What a pain in the butt. That was poor thinking on my part. So that end mill, not particularly accurate. It's a Chinese end mill, and look at that slop. That is terrible. I did not expect that at all. Fortunately, I have some Loctite that'll work there. Or perhaps I'll just epoxy it in place. Alright, now let's move along. So before I took this guy out of here, I milled some flats into this side so that I could hopefully find a way to realign it, because I just realized I need to put it back in here. And it turns out that I can use the back of the jaw and the square, and I'm good to go. I mean, this isn't an ultra precise procedure anyways, so it's not going to be a problem. However, I am going to have to find center, so I'm going to have to get out the Blake coaxial indicator again, or the copy of the Blake anyways, and find my 0 point again, because what I want to do now is I want to mill off this half of the brass bit that I glued in here with some epoxy. Hopefully the epoxy will hold. Alright, so we're going to try and plunge cut this. We're going to speed up the mill to about about 1200 RPM. We'll see how this goes. You want to take a smaller bite just to see how it goes. I put a depth stop on this guy. Okay, that's actually going really well. Thousandth and a half left. I'm going to lock my x-axis. And we're going to come over here. So now I have to do the final pass. So I have to do the final pass straight across because I'm coming down with a curved surface. So right now these have curves in them. So for the very finished pass, I've got to come straight across. So now I can loosen this up, do my last 1.3 thousandths. Hopefully this won't squeak too much. Let's lock it off at the bottom. Not bad. It's a lot of stick out. Okay, we're going to call that good. So the curved part of the D is complete. Easier than I thought it was going to be. I had concerns about this much stick out. The reason why this is so long is I want to be able to cut off more than one of these because it's a fair amount of work to make. So hopefully that'll work out. I'm still not sure. So I used the flats I milled into the top of this while I was still in the vise before to set this up based on the top of my vise jaws here to get it square. So we should be now. So I don't know how well you're going to be able to see this, but I'm going to try and cut this guy. And we're going to go in back gear, so we're going to shoot for, I don't know, about 140 RPMs. Let's see how it does. This is pretty thin and soft material, so okay. So I don't know how much of that you saw, but the advantage of the direction I had the blade going was it was pushing into the work. So I was hoping that would help, and actually it looked like it didn't deflect too much. So there's the slot in it that the T is going to go in, so I need to make a flat piece in back. I need to make the T that's going to go down, and I need to press this together a little bit because it expanded upon being cut. Built-in tension. So I have the 50,000 stock mounted to a piece of aluminum. It's super glued on. And first thing I'm going to do is I'm just going to take this aluminum cutting bit and I'm just going to run it around the outside edges to square it up relative to the travel of the mill. The material is much larger than I need, so I've got plenty of room to work with, and this way I didn't have to worry about aligning it to the aluminum block or anything like that. And I'm just going to cut it square. Then I'm going to come back with my indicator and I'm going to find this corner over here, and I'm going to set my 0 for that corner. So first step is going to be find my Z-axis 0. Let's take this out of back gear. .1200 RPM. Let's find my Z0. Just touch the aluminum a little bit. Nice. And the bottom. Now our sides are all square. relative to the table. So now I just need to find this point in the corner here after I deburr it a little bit and get my 0. Alright, so next up we're going to go Z-axis 20 thousandths, the first one, except for the end part. Now we're just going to cut out this piece in 2 passes. Do a 20 thousandths pass first. Make that 3 passes. Next we're going to do the upright of the T, and we're going to have, we don't have a ridge on both sides in this one, just on one side. This flat side here will meet up with the cross piece on top. So here are the 2 parts. Now we're going to try and remove them without damaging them. By heating them up, and I'm just going to use a little torch. So we're going to try and remove these guys off of here. I originally tried this with the parts horizontally, but there we go. My problem was that the torch kept going out because it didn't want to run leaning down. Alright, so here's my 2 pieces. The other part's still attached nicely. And these will be connected together like so, which I haven't quite figured out how I'm going to do yet. I left little ridges on either side just to accent the shape. And then those guys, let's see, this will be mounted in here sort of like this, and this will be mounted like this. And then I will fill it with epoxy and cut off the excess. And now you can sort of see the DT, right? So here's the part lightly glued up. These pieces are all different heights, but I will mill them all flat once I'm done. So now I just need to make the piece that goes around this outside to contain the epoxy, and we should be pretty close to good. And here we are on the last couple passes, trying to get this to 1/1000ths. So we're going to take about 15 thousandths this pass. In the last pass, we're going to slow the feed rate down quite a bit. Just to clear the chips and cool it off a little bit. Should have about 10 thousandths left. Looks like it's 11 thousandths. We don't have to be super precise. Take the last 10. So now we're just going to part this guy off. So next up, we take the outside piece that I made. Sorry, it's tough doing this with one hand. Slide it over where it fits. and then fill the entire center section with epoxy. I'm going to be using this JB Weld, and first I'm going to heat these up in some hot water to make them very fluid so that they'll pour in more easily, and then we're just going to fill this guy up. Hopefully we'll be able to do a good job. If I really wanted to be careful, I'd use a vacuum pump to get air bubbles out, but I don't have one at the moment, so we're just going to try it. So I've got my epoxy in some really hot water. It's just under boiling, and I'm letting it heat up so that it'll become very fluid, and it'll probably make the reaction happen faster, so my setup time won't be as long, but this is some pretty slow epoxy, so hopefully it'll be okay. Next up, we're going to pour it into here, mix it in here, and pour it into the mold. So let's see if we didn't screw up too badly here. All right, let's mix it up. All right, let's see if we can pour it in. All right, now we just need to let this cure. It's going to take overnight, maybe a little faster since I heated it up so much, but we'll come back tomorrow and we will start facing off this end until we get to the good stuff. Hopefully this experiment will have worked. So here's the part after the epoxy is cured for 24 hours. I'm going to take this part to the bandsaw and cut off the T here, and then we're going to try and face it on the lathe. And this epoxy is kind of brittle, so I'm not quite sure how it's going to machine at all. It may not machine well, and this whole thing may be a disaster. But also, I was kind of hoping this epoxy would be darker than this. I thought I remembered it being darker, but this is sort of a medium gray. Anyways, let's trim this off, put it in the lathe, and see how we fare. So we've got a positive rake insert here for aluminum. Hopefully that will be really sharp and cut right through this stuff, but I really have no feel for how the epoxy is going to cut. Is it going to turn to powder? It's going to shatter? And then how's the positive rake insert going to deal with the stainless steel when I go to take a skim cut? But let's just give it a shot. We're going to go really low feed rates. Alright, so here's my Z0. So try 20,000 steps of cut, see how it goes. Oh, you know, I might want to change the angle of my cutter to give more clearance, but let's let it go for now. Eventually it's going to be an interrupted cut too, once we get to the brass center part. So we're going to have to sand and polish this to get a nice finish out of it, I think. Alright, let's see what that kind of looks like. Now I sort of see that, and that is, oh, there's some air bubbles in there. That's unfortunate. Alright. Kind of a fast feed rate for the stainless. Probably don't want to generate too much heat, although the chip breaker is engaging nicely. have a bit of a cold. Still haven't gotten down to the D. Whatever happened to the D? Stuff is messy. I see part of the D. So next up, I think I am going to try and switch to a positive rake insert and take a 1/1000th pass and see if I can clean it up a little better. I don't know that I'll be able to, but we're going to give it a shot and see if there's any improvement. This epoxy does not cut very nicely at all. Stainless got a nice finish. I think the epoxy might be kind of hopeless. Oh, that's not so bad. All right, there we are. So now I can slice off small pieces of this and insert it, but let's see how it sands up. I'm going to try and finish this and see how well it takes a finish. I'll be right back. So here's the final product, and could be better. I need a vacuum chamber to suck the air bubbles out of the epoxy. I stirred it well, but apparently not all the bubbles rose to the surface. Also, heating it might have caused it to cure faster, which locked the bubbles in place. So not ideal. I'd also like a darker epoxy than this one because I think it might look nicer with more contrast. But this is the idea because this DT goes all the way through, so I can cut off an 1/8 inch slice off this and then bore a hole and put it in my work to identify that I made it. This was my first attempt, and it was just an idea to see how it went, and I think it turned out pretty good. So one more thing, I could put a clear coat over it and sort of simulated that with some alcohol here. I don't know, that might be a little better, although it's kind of funky. Just another thought. Thanks for watching. Hope to see you next time.